Hello, dear members and participants of the conference. It is my pleasure to present to you application of digital image processing for expanded gamut printing with effect of saving material resources. One of the primary objectives in modern printing is achieving high-quality color reproduction that closely matches to the original image. For color printing process has significant drawback. Its color gamut is limited compared to the gamut of the monitor and the gamut of real colors. Spot colors are generally used to reach colors that are outside of the gamut of process CMYK printing. The whole process is spot colors printing is inefficient. It is expensive and arduous, and represent custom manufacturing which is difficult to justify in a giant economy. Therefore, in recent years, the popularity of research in the field of multicolor printing has increased. These studies concern the possibility of replacing spot colors with classic four-color printing, with addition or 2 or 3 color inks. Such printing was named extended gamut, expanded gamut, and multi-primary printing. According to research by the Toronto Research University, the expanded gamut provides reproduction of large range of colors and 90% of spot colors from the Pantone solid coated library. The relevance of multicolor printing is confirmed by a research project from the Fogra Institute, which has also used 7 colors: cyan, magenta, yellow, black, orange, green, violet. It's necessary during the process of color separation of images take into account the actual color characteristics of the inks and the technological conditions of the printing process as much as possible. This task is assigned in the ICC profile. Equations proposed by physicists and researcher in the image reproduction, Neugebauer, describe the principle of image synthesis on the imprint with the colored inks. The overall objectives is to perform analytical solutions and different image processing methods to evaluate color reproduction in multicolor printing. A color separation is needed to convert color information from RGB to CMYK or CMYK OGV. The authors of this present paper generalized the characteristic of existing tangent color spaces to additive and subtractive system to create a color space that will provide a perfect conditions for calculating colors. Also, the nonlinearity of reproduction of cyan ink and cyan, magenta, yellow, and black ink was determined by color red, green, and blue, respectively. Similarly, the nonlinearity of additional inks, orange, green, violet, also was calculated. The theoretical model of multi-primary color mixing is described by the vector equations. This is the fundamental complexity of the solutions of the Neugebauer equations, since the same color can be practically synthesized by different ratios of colored and black inks. Modified Neugebauer equations in the color space ICAS have certain properties. The chromatic coordinates of two colors are proportionally to a coefficient represented by the scalar value, Sk, assuming the same color tone but differ in achromatic proportions. A color chart consisting of 22 Pantone solid coated library color samples. Each sample has its CLAB values that must be followed during the printing process. The image of test chart colors was converted to multi-channel ICC profile Fogra 55. As a result, we obtained 7 channels CMYOGVK instead of the 3 RGB. Thus, we received new CLAB values and relative dot areas of printing inks. The second stage of our research was processing a test chart in the ICAS color synthesis software. First, it is necessary to enter value of basic vectors of primary and secondary color inks. It can be seen the user interface in the ICAS color synthesis software. The nonlinearity of the gradation reproduction of the printouts of CMYK inks was determined, which on average is 1.64 of CMY and 1.63 for black. The values obtained indicate the increase of screen dots for printing inks. In order to compensate for this increasing, we need to consider the nonlinearity index when preparing image for printing. Based on an analysis of color projections, the color representation is reduced to 6 color segments in the 7-color CMOIGV printing process, depending on the hue. Therefore, regardless of the number of N-color printing, the ICAS color space completely separates the black K ink from the remaining N-colored inks. The method offers the optimal color inks for reproducing any color on the image. Figure illustrates the comparison of color spaces between the original and printing processes. Gamut volume quantifies the size of the color space. The obtained values confirm the 7-color printing will enable to reproduction of more colors compared to 4-color printing. The study aimed to calculate the color differences between the original CLLB values of spot colors and analytical solutions of the modified Nigabow equations that are used for image separation in ICAS color print technology. Obtained values of color differences from ICAS color print of such color samples as orange, some red, are smaller compared to the same colors from ICC profile. The largest value of color differences was obtained for sample of Pantone colors of purple, violet, and blue shades. The average value of color differences is 7.47 for ICC profile and 6.13 for ICAS color print information technology. The average value required for total area coverage to reproduce the studied spot colors is 133% for the ICC profile based on FOGRA 55 and 139% for the ICAS color print technology based on analytical solutions. The maximum value of TAC is 107% and 100% respectively. We have observed the values of inks falls in the range 1–3%, which makes the process of manufacturing printing plates and the printing process more complicated. Thus, increasing the color gamut of the printing process through the addition colors does not complicate the process of color separation of the image, but rather improve the accuracy of color reproduction, including spot colors. The color separation ICAS color print technology resulting in accurate reproduction or saving of colored inks. A matching accuracy to experimental data ranging from 0.35 to 8.6 delta E, affirming the reliability of developed ICAS color print technology. A promising direction is the application of developed separation technology for digital and flexographic printing. In digital printing, ink is supplied in a controlled manner, making efficient use of color inks crucial. In flexographic printing for labeling and packaging, substituting costly spot inks with tried inks and a few additional ones, can conserve resources without compromising color reproduction quality. Thank you for your attention.